Alright, this is section 5.5. Please go ahead and title your notes. We are solving absolute value inequalities. This is new. We've solved absolute value equations, correct? Yes. We've solved inequalities, correct? Yes. We're putting them together. We're solving absolute value inequalities. When you solve an absolute value equation, how many equations do you solve? Two. It's always two. Now, in an inequality, we've solved regular inequalities and we've solved compound inequalities. When you solve compound inequalities, there's two words that we look for. One is or, and the other is and. So you've got to be looking for those things when you are solving these absolute value inequalities. We're solving two inequalities and we're thinking about ands and ors. So today our focus is just going to be on the ands. All of our symbols today are going to look like this. Less than or less than or equal to. Please put that into your notes. These are all ands. Less than or equal to. I've got an easy way for you to remember that when you see less than, that means and. So think of it this way. If we write less than, I know that's not how you really spell than, but less than has the word and in it, right? Maybe an easy way for you to remember something silly to help you recall what that less than indicates. So if you see the less than symbol, we're talking about and. And again, this only applies to absolute value inequalities. The less than symbol means we're talking about and. So here are the things that we are going to consider when we're solving these inequalities. Number one, the expression inside the absolute value is non-negative, or it's positive. Logan, are you with us? Two, the expression inside the absolute value is negative. That's where these two cases come into play. When we solve absolute value equations, we solve two cases. We left what was in absolute value was positive and the other was equal to a negative when we solve both. And we're going to do the same thing just with an inequality. So if you will copy down this first example, let's talk about this. The absolute value of x is less than 7. Remember, absolute value was really talking about a distance from 0, wasn't it? So when we have the absolute value of x is less than 7, this really means that the distance from 0 is less than 7. The distance from 0 is less than 7. Well, I want to know what numbers can I put on the number line that's going to give me a distance of less than 7 from 0. So we can set up a couple of inequalities that will help us to easily come up with those numbers. Again, we are working with the symbol less than. What does that indicate if it's less than? And or? And. So the first thing I want you to do is write the word and. Now, we're going to set up our inequalities on either side of that word and. The first inequality we're going to say is x is less than 7. X is less than 7. And when we set up our second inequality, we're going to say that x is greater than negative 7. Okay. Now, I did two things to my inequality. The first thing is I switched my symbol, and I changed my sign. I flipped my inequality symbol, and I changed my sign. And you're going to need that to do both of those things when you set up that second inequality. Now, in our case, is there any solving to be done for either one of these inequalities? There's not. So we're graphing this as an and compound inequality, just like we were doing. So draw the number line. On our number line, we're going to include numbers from negative 7 all the way to positive 7. Extend my graph a little bit there. So we have less than 7. So open circle at 7 and graph is going to the left. We have greater than negative 7. Open circle at negative 7, graph is going to the right. When we graph ands, what are we looking for?
The numbers in between.
The solutions are common.
I need more. What are we looking for?
Numbers in between.
Not the numbers. More. What do you mean more? The numbers that satisfy both. The numbers are where the graphs overlap. That was our key word there. I don't necessarily want what's in between because the endpoints could be solutions. So I don't want you to think in between. I want to know where do our solutions overlap? Where do we share the solutions? Well, where do they share solutions?
7 and 7.
From -7 to 7. Is -7 included? What about +7? It's not. So we will put open circles at those endpoints to indicate that they're not included. They are endpoints, so they're an important part of our graph. And then everything here in the middle, everything between those two endpoints are our solutions. Now, in addition to the graph, we need to write a compound inequality that's describing this piece right here. So we're going to say that all of our solutions x are between what two numbers? -7 and +7. Let's start with x and +7. Is x bigger than 7 or is x smaller than 7? So what symbol would I use if it's smaller? Could it be equal to 7? No, because we have an open circle. Now here, let's read this backwards. Is x bigger than -7 or is x smaller than -7? X is bigger, so think backwards here. What symbol am I going to put? Less than. This is saying that x is greater than -7. Is that true? Because -7 is less than x also means x is greater than -7, doesn't it? So we flip it around. And again, I don't want that to be equal to because we do have an open circle. So again, your graph and this compound inequality are what I am looking for. Let's look at some more. Oh, this example. This is read the absolute value of m plus 2 is less than 11. This less than symbol indicates and or, you tell me. And. Less than is and. Okay. So I want and in the middle, and on either side of that word and, let's set up our two inequalities. The first inequality is going to be exactly what we have. M plus 2 is less than 11. For the second inequality, it's going to be m plus 2 is greater than -11. For that second inequality, we need to flip our symbol and change the sign. Now notice when I'm setting up these two inequalities, am I including absolute value bars?
No.
I'm not. I'm just setting up the inequalities. They are not absolute value bars. The absolute value bars are telling me that I need the two inequalities, and that's really about all they do at this point. Let's solve. How do you solve the first inequality? So we're left with m is less than 9. On the right-hand side, what would you do to solve? Subtract 2. M is greater than -13. So let's draw our graph, and let's graph numbers that are less than 9 and greater than -13. So we're going to go all the way from -13 to +9. So we have less than 9, and we have greater than -13. Okay, this is an and inequality. What are we looking for from the graph? Where they overlap? Well, where do our solutions overlap or our number lines overlap? Between negative 13 and 9. Is negative 13 included? Is 9 included? Neither one are included. So we'll include open circles as our endpoints. And draw the line in between to show that those are our solutions right there in the middle. Make sure if you guys do this third graph on your number line that I can clearly see where your overlapping region is. Sometimes it's difficult, especially if you have a worksheet and you're drawing it in on a number line. Make sure you do it thick enough that I can tell exactly where you're wanting me to show, or where you're wanting to show where the graphs overlap. Now, in addition to a graph, we need to write our compound inequality. We're going to say that our solutions, which are m, are between what two numbers?
Negative 13.
Negative 13 and 9. And of course, we always put it in this order. Smallest number to largest number. That's how we read things. So let's start with between m and 9. Are our solutions less than 9 or are our solutions greater than 9? Less than 9. Now let's read backwards. Are our solutions less than negative 13? Or are our solutions greater than negative 13? Our solutions are greater. So if we're reading backwards, it's really going to be less than, isn't it? Our solutions are greater than negative 13. If we were to flip this inequality symbol, flip it around, isn't this going to read m is greater than negative 13? Okay. So again, I want the graph and inequality, just like we were doing. How about this one? The absolute value of y minus 1 is less than negative 2. Less than symbol, what does that indicate? Less than indicates and. Please write the word and. On either side of that word and, let's set up our two inequalities. The first one is going to be y minus 2 is less than negative 2. And the second one's going to be y minus 2 is greater than positive 2. Oh, I'm sorry. I did put 2 instead of 1, didn't I? Change that. There we go. Now we have to write an inequality. To solve the inequality on the left-hand side, what would you do? Add 1. So y is less than negative 1. On the right-hand side, what would you do to solve? Add 1. Y is greater than 3. So I want numbers that are less than negative 1 and greater than 3. Can you think of numbers that are less than negative 1 and greater than 3?
No solution.
So there's no solution.
I do want you to graph this. Your graph helps me to know that you know it's a no solution. Because on an and inequality, what are we looking for?
Numbers that satisfy both.
I want numbers that satisfy both. I want to know, where do our graphs overlap? Well, where do they?
They don't.
They don't. And if they don't overlap, we don't have any numbers in common. There's not a number that's bigger than 3 and less than negative 1. So we would say that it is no solution. And you do need to state no solution or use the symbol no solution 0 with the line through it. I want to do one more with you. This is going to be the problem that we're going to do together. This is where the absolute value of n plus 3, all divided by 4, is less than or equal to 6. This is and because it has a less than symbol. So let's set up our inequalities. Is it going to matter that we have a fraction? No, it's the only thing that changes is our symbol and our sign of the 6. Everything else is exactly the same. N plus 3 divided by 4 is less than or equal to 6. For our second inequality, n plus 3 is divided by 4 is greater than or equal to negative 6. How would you solve these inequalities? Multiply by 4. Get rid of that denominator. Make sure you do multiply both sides by 4. So we have n plus 3 is less than or equal to 24. What would you do next?
Minus 3.
Subtract 3. N is less than or equal to 21. On the right side, we are, of course, going to multiply by 4, which I've started to do. So let's clean it up a little bit. N plus 3 is greater than or equal to negative 24. Subtract 3. So n is greater than or equal to negative 27. Negative 27. So my number line, I'm going to include numbers from negative 27 to positive 21. So we're greater than or equal to negative 27. Make sure you use that closed circle. And less than or equal to 21. Notice on my number line I skipped. I went by 3s, I should say. Because 21 and negative 27 are both divisible by 3, so I was thinking I could fit both numbers. I'll save it a little bit around. But you cannot just put 21 and negative 27. I need more stuff. I need more information on your number line. Now, clearly from our graph, we're looking at the overlap. Well, where do our graphs overlap one another?
Between negative 27 and 21.
Between negative 27 and negative 21. Is negative 27 included?
Yes.
Yes. How do we know?
It's a closed circle.
Closed circle. What about 21? Is it included?
Yes.
Again, we know that because of the closed circle. So we use closed circles as our endpoints and then draw the line connecting the two. We need our compound inequality that describes this graph. Saying our solutions n are between what two numbers? Negative 27 and 21. So is n less than 21? Are solutions less than 21 or are solutions greater than 21? Less than. Could it be equal to? Yes, less than or equal to. Now what about our solutions in negative 27? Are solutions bigger than negative 27 or are they smaller? So what symbol will we use? Less than or equal to as well. Just a reminder, guys, when you're setting up your two inequalities, that second inequality, you're doing two things. You're changing your symbol, your inequality symbol, and the sign. That's the only two things you change. You don't do anything to what's in absolute value. It stays exactly the same. When you're writing your solution, I need the graph, and I need the compound inequality that describes that graph. I do have a few problems for you to try, and I do expect you guys to utilize your time here in class. From page 312, 1 through 3, 8 through 13, 22, 23, 25 through 27. That's 25 through 27, and 29. And please utilize your time in class.